Today we're diving into the fascinating world of programming languages. Whether you're a complete beginner or just curious, understanding programming languages is the first step to unlocking the power of computers. Programming languages are the tools we use to communicate with machines, giving them instructions to perform tasks. From building websites to creating apps, programming is everywhere. In this video, we'll explore what programming languages are, why they matter, and how they shape our digital world. Let's start our journey by understanding the basics and setting the stage for deeper exploration. Programming language is a formal set of instructions that allows us to tell a computer what to do. Think of it as a special language designed for humans and machines to communicate. Just like we use English or Spanish to talk to each other, programmers use languages like Python, Java, or C++ to talk to computers. Each language has its own rules called syntax and its own strengths. Understanding this concept is key to grasping how software and applications are created. Let's look at why there are so many different programming languages. You might wonder why there are hundreds of programming languages. The answer lies in the diverse needs of technology. Some languages are better for building websites, while others excel at handling large amounts of data or controlling hardware. For example, JavaScript is popular for web development, while Python is favored for data science. Each language is designed with specific goals in mind, making it more suitable for certain tasks. This variety allows programmers to choose the best tool for the job, much like a chef selects the right knife for each ingredient. Programming languages are often categorized as high-level or low-level. High-level languages like Python or Java are closer to human language and easier to read and write. They handle many details for you, making development faster and more accessible. Low-level languages such as assembly or C are closer to the computer's own language. They give you more control over hardware but require a deeper understanding of how computers work. This distinction helps programmers pick the right language based on their needs and expertise. Let's take a look at some of the most popular programming languages today. Python is known for its simplicity and versatility, making it a favorite among beginners and professionals alike. JavaScript powers interactive websites and is essential for web development. Java is widely used in enterprise applications and Android development. C++ is valued for its performance and is often used in game development and systems programming. Each of these languages has a unique place in the tech world, and learning any of them opens up exciting opportunities. Its core programming is about solving problems by giving computers step-by-step instructions. Programmers write code, which is then translated into a form the computer can understand. This process involves writing, testing, and refining instructions until the desired outcome is achieved. Whether it's a simple calculator or a complex video game, every program starts with a clear set of instructions written in a programming language. The ability to break down problems and think logically is at the heart of programming. Every programming language has its own syntax, which is like grammar in spoken languages. Syntax defines how you write instructions so the computer can understand them. Semantics, on the other hand, is about the meaning behind those instructions. Getting the syntax right is crucial. One small mistake can cause errors. As you learn to program, you'll become familiar with both the rules and the logic that make your code work as intended. Programming languages can be either compiled or interpreted. Compiled languages like C or C++ are translated into machine code before they run, making them fast and efficient. Interpreted languages such as Python or JavaScript are read and executed line by line, which can make development quicker but sometimes slower to run. Understanding this difference helps you choose the right language for your project and anticipate how your code will perform. Algorithms are step-by-step procedures for solving problems. In programming, algorithms are written in code to perform specific tasks like sorting a list or searching for information. Good algorithms make programs efficient and effective. Learning to design and implement algorithms is a key skill for any programmer, as it helps you tackle complex challenges and create powerful software solutions. Variables are like containers that store information in a program. Data types define what kind of information a variable can hold, such as numbers, text, or more complex data. Understanding variables and data types is fundamental to programming, as they allow you to manage and manipulate information effectively. Each language has its own way of handling variables, but the core idea remains the same across all programming languages. Control structures are the building blocks that determine how a program makes decisions and repeats actions. Common control structures include if statements, loops, and switches. These structures allow your program to react to different situations and perform tasks multiple times. Mastering control structures is essential for writing flexible and powerful code that can handle a variety of scenarios. Functions and procedures are reusable blocks of code that perform specific tasks. By organizing your code into functions, you make it easier to read, maintain, and debug. Functions can take inputs called parameters and return outputs. This modular approach is a cornerstone of good programming practice, helping you build complex programs from simple, manageable pieces. Object-oriented programming, or OOP, is a popular way of organizing code. In OOP, you create objects that represent real-world things, each with their own properties and behaviors. Languages like Java, Python, and C++ support OOP, making it easier to model complex systems. This approach helps keep code organized, reusable, and easier to manage as projects grow in size. Procedural programming is another common style, focusing on a sequence of instructions to perform tasks. It's like following a recipe step by step. This approach is straightforward and works well for many types of problems. Languages like C and Pascal are known for their procedural style, and understanding this method gives you a solid foundation for learning other programming paradigms. Functional programming treats computation as the evaluation of mathematical functions. It avoids changing state and mutable data, focusing instead on pure functions and immutability. Languages like Haskell and Scala are known for their functional approach. This style can lead to more predictable and reliable code, especially in complex systems where managing state can be challenging. Scripting languages are designed for automating tasks and writing short programs quickly. They're often used for tasks like automating file management, processing data, or controlling other software. Python, JavaScript, and Bash are popular scripting languages. Their simplicity and flexibility make them ideal for rapid development and prototyping. Not all languages are for programming logic. Markup languages like HTML structure content on the web, while query languages like SQL are used to retrieve and manipulate data in databases. These languages have specialized purposes and are essential tools for web developers and data analysts. Choosing the right programming language depends on your goals. If you want to build websites, JavaScript is essential. For data analysis, Python is a great choice. If you're interested in building mobile apps, consider learning Java or Swift. Each language has its own strengths, and the best choice is the one that fits your project and interests. There are countless resources available for learning programming languages. Online tutorials, coding bootcamps, books, and interactive platforms make it easier than ever to get started. Many languages have strong communities that offer support and guidance. No matter your learning style, there's a resource out there to help you on your programming journey. Learning to program is like learning a new language. It takes practice. Writing code regularly helps you internalize concepts and improve your problem-solving skills. Don't be afraid to make mistakes. Each error is an opportunity to learn. The more you practice, the more confident and skilled you'll become. Debugging is the process of finding and fixing errors in your code. It's a crucial skill for every programmer. When something doesn't work as expected, debugging helps you identify the problem and correct it. Learning to debug effectively will save you time and frustration, and it's an essential part of the programming process. Version control systems like Git help programmers manage changes to their code over time. They allow you to track revisions, collaborate with others, and revert to previous versions if needed. Mastering version control is important for working on larger projects and collaborating with teams. Open source software is code that's freely available for anyone to use, modify, and share. Many programming languages and tools are open source, which encourages collaboration and innovation. Contributing to open source projects is a great way to learn, gain experience, and connect with the programming community. Integrated development environments, or IDEs, are software tools that make programming easier. They provide features like code editing, debugging, and project management all in one place. Popular IDEs include Visual Studio Code, PyCharm, and Eclipse. Using an IDE can boost your productivity and help you write better code. Libraries are collections of pre-written code that you can use to add functionality to your programs. They save time and effort by providing solutions to common problems. For example, Python has libraries for data analysis, web development, and more. Learning to use libraries effectively is a key skill for modern programmers. Frameworks are larger structures that provide a foundation for building applications. They include libraries, tools, and best practices, making development faster and more organized. Popular frameworks include Django for Python and React for JavaScript. Using frameworks helps you follow industry standards and build robust applications. APIs, or application programming interfaces, allow different software systems to communicate with each other. They let you use features from other programs or services in your own code. For example, you can use an API to access weather data or connect to social media platforms. Understanding APIs is essential for building modern, connected applications. Good documentation explains how code works and how to use it. It's essential for both individual projects and large software systems. Well-documented code is easier to maintain, share, and improve. As you write programs, make it a habit to document your work clearly and thoroughly. Security is a critical aspect of programming. Writing secure code protects your programs and users from threats like hacking and data breaches. Learn to follow best practices such as validating input and managing sensitive data carefully. Security should always be a priority, no matter what language you use. Performance optimization means making your code run faster and use fewer resources. This can involve choosing efficient algorithms, minimizing memory usage, and writing clean, concise code. Optimizing performance is especially important for large or complex applications where speed and efficiency matter most. Cross-platform development allows your programs to run on different operating systems like Windows, macOS, and Linux. Some languages and frameworks are designed to make this easier, helping you reach a wider audience with your software. Understanding cross-platform development is valuable for building flexible and accessible applications. Mobile programming focuses on creating applications for smartphones and tablets. Languages like Swift for iOS and Kotlin for Android are popular choices. Mobile development requires understanding unique challenges such as touch interfaces and battery management. It's a rapidly growing field with endless opportunities. Web development involves building websites and web applications. Key languages include HTML, CSS, and JavaScript. Web developers create everything from simple pages to complex online platforms. Understanding how these languages work together is essential for anyone interested in the digital world. Game development is a creative and technical field that uses programming to build interactive games. Languages like C++, C, and Python are commonly used. Game development involves graphics, sound, and user interaction, making it a challenging but rewarding area for programmers who love creativity and problem solving. Data science uses programming to analyze and interpret large amounts of data. Python and R are popular languages for data science, offering powerful libraries for statistics, visualization, and machine learning. Data science is transforming industries by turning raw data into valuable insights. Artificial intelligence, or AI, relies heavily on programming languages to create smart systems that can learn and make decisions. Python is widely used in AI for its simplicity and powerful libraries. AI is shaping the future, from self-driving cars to intelligent assistants, making programming skills more valuable than ever. The Internet of Things connects everyday devices to the Internet, allowing them to communicate and share data. Programming languages like C and Python are used to develop IoT applications, from smart home devices to industrial sensors. IoT is expanding rapidly, creating new opportunities for programmers. Cloud computing allows you to run programs and store data on remote servers instead of your own computer. Programming languages like Java, Python, and Go are commonly used in cloud development. Cloud computing offers flexibility, scalability, and cost savings, making it a key area for modern programmers. Embedded systems are specialized computers built into devices like cars, appliances, and medical equipment. Programming languages such as C and C++ are often used for embedded development because they offer precise control over hardware. This field requires a deep understanding of both software and hardware. Learning programming languages opens up a wide range of career opportunities. From software development and data science to cybersecurity and game design, programming skills are in high demand. Whether you want to work for a tech giant or start your own business, programming is a valuable asset. Programming languages continue to evolve, with new languages and tools emerging all the time. Trends like artificial intelligence, quantum computing, and automation are shaping the future of programming. Staying curious and adaptable will help you thrive in this ever-changing field. Programming communities, both online and offline, are great places to learn, share knowledge, and collaborate on projects. Platforms like GitHub, Stack Overflow, and local meetups connect programmers of all skill levels. Being part of a community can accelerate your learning and open doors to new opportunities. Women have made significant contributions to programming, from Ada Lovelace to modern leaders in tech. Encouraging diversity in programming leads to more creative solutions and a stronger industry. Everyone is welcome in the world of programming, and diverse perspectives drive innovation. Programming isn't just for adults, kids can learn to code too. Tools like Scratch and Blockly make programming fun and accessible for young learners. Early exposure to programming builds problem-solving skills and confidence, preparing kids for a digital future. We've covered the essentials of programming languages, from what they are to how they're used in the real world. No matter your background, learning to program is an empowering skill that opens up endless possibilities. Start small, keep practicing, and enjoy the journey. The world of programming is waiting for you to explore and create.